All right, welcome back. We're working on finishing out as many things on the cockpit as we can while we wait for it to warm up. Today what we're going to be working on is fitting this cover in the back. Now the first question is, the plans say just use the template for the back firewall to get set the curvature, but it's a little forward and you can see that the turtle back gets larger as it goes forward. So we started by cutting something that was exactly the same size as the firewall and putting it where we think we want to put this cover, and seeing that it was about 3/4 of an inch shy on the top and about a 1/2 inch shy or a little bit less on the side. So we made this cardboard piece that fits where we want it to. Of course, when we look at this piece that we previously laid up according to the plans, or didn't read the plans close enough, depending on how you see it, you see that we're going to be a little tight on this piece here. The first question is really, where do we want this cover to sit? And so in order to figure that out, we got a lot of equipment that's got to mount on that back firewall, and the question is, what's the thickest piece of equipment? I think it's the battery. So I actually 3D printed a model of the battery we're going to be using, so I don't have to buy it now and let it sit on the shelf and get older. So that's one thing, but let's just see what else is going to go on that back firewall. So here's our general arrangement diagram. Let's zoom in back area here where we've kind of got the components. See, we're at this point a little oversubscribed, since we've got these, let's see, we got these 3 contactors here, and this is the ignition system, light speed ignition system, and that's not all going to fit as it is right now, but I think I can rearrange these. I think I'm going to get rid of one of these contactors and rearrange this stuff to get it all in here. The real question is what is the thickest one, because battery is the thickest thing that's going to go on the back of the spar. And I made all of these models from the information from the manufacturers. The main battery here from Earthex, we just pulled out the 3D printer and printed that puppy up. Oh yeah, so we'll see once I trim this down, which is a little smaller than this cardboard piece, how big a gap we got and if we can live with it, or if we need to make this a little bit bigger or do something else. So this foam piece is, I don't know, 1/4 to 1/2 inch too small. And the other issue is that even when it does fit, it leaves these holes exposed, and the seats cover over this area, but the center section is also exposed. And I'm not sure I really like that idea. So I think what I'm going to do is I'm going to just make that cover all of this area. And it just can be one piece of, one ply of fiberglass, maybe 2, down in this area, because it'll be supported, and maybe I'll put a couple of pieces of foam behind it just for rigidity, at least on the bottom or something like that. But it's just a cover, so we don't have to make it super strong or heavy. But let's mock it up out of cardboard first. Well, I wish it were that easy to make it out of fiberglass. I used laser level to put marks on the top, where in the same plane as the back of the front of the spar back there. So here's our cardboard template with what we've got made so far, and this is the extra foam that I've got left over. Yeah, it's ugly, but I think it's going to work out just fine. We'll just fill in these gaps with a little bit of micro. And again, this isn't structural, it's just a cover. 1 ply of bidirectional fiberglass on here. We're going to want to put a ply here and have it overlap up there, but that's 2 plies up there, so this is all going to be more or less protected. So I think 1 ply but down here is going to be fine. Put this down and mark it and trim it, and then make sure that everything fits in there before we do this layer of fiberglass, because I think I'm going to have to cut a couple of a lot of reliefs in there for the 2 seats. All right, we just did a fit check on this. Took more than a couple iterations to get this fitting back there. And then I pulled the seat backs out and just made sure that they weren't going to be interfering, which they are not. So I don't have to make any changes with that. It's noticeably heavy. I don't know if I was just too rich with the layup or whatever, but anyway, tried not to be, but it's feeling heavy. Okay, after a few iterations, we got this fitting in here, flush up against everything in the back. The last couple things we need to do is we need to make 4 holes for our seat belts. And to prevent this, some clips. Plans just say use some Velcro, which is fine. My experience with Velcro is that over time, not so much that the Velcro loses its stickiness, it's just that the Velcro to the fiberglass fails, and now you just got a kind of a sticky mess. But in this case, I have a different thought that I'm going to try for funsies. All right, we got our 4 cutouts marked, make them into slots with rounded corners. And now just cut these out with the Dremel. All right, here's my idea. Bottom stop on the top, a couple of clips. And there's Rev 1. It's a little too long for the bottom. That's going to be fine for the top. And this front piece, I think, can actually be twice as tall. So I've spent way too long thinking about and screwing around with trying how to get this panel to sit in the back of the firewall without using Velcro. Velcro would have been by far the fastest solution. But I kind of got 2 choices at this point. For the bottom, I made these little clips or stops, and I'm pretty happy with the design of those. I think I showed you those on the computer earlier. And so that'll hold the bottom from moving, and then the top, you know, I got to secure it some way. And my first thought was this sort of clip thing where, you know, this will just deflect and it'll snap in there, and then in theory I can push it and then pull it out again and bond. This has got the little nubs that we designed for grabbing to epoxy, and we'll just bond that to the top. The other option I thought about was essentially the same way we did the armrests, where we've got a fastener going into a bracket on the other side, and instead of using that expensive nut plate situation that we did on the armrests, I thought that maybe I would just use some of these automotive panel clips, which I definitely am going to use when we go to bond. Let's see. Which I'm definitely going to use when we go to put this, which is the cover for the landing brake actuator, and I'm going to try to figure out how to use these to affix this to a couple of brackets. But, you know, I kind of came up with this plan on this one. I could do this. I think what I'm going to do is there's a gap right here, and I think I'm just going to go ahead and put this in and see if it'll snap in that gap. I won't have to, you know, if I put it right here in the middle, I think I'm going to have to cut a relief in there that I would probably not want if I go with this plan. The problem with this plan is trying to line up this thing with the bracket that you've already bonded in the back, which means that you got to kind of carve out a slot here. I don't know. None of these is, there's not a lot of great solutions here. This is what I'm spending, as I said, way too much time thinking about. Should just use Velcro. Here's Rev 4 of my panel stop. And there's Rev 5. I had this little nub here. And now, when we put that on there, that satisfying little click. So here's the next generation of the panel clip. So we got our little nubs here that'll glue on to the top, and then this can go into the panel to make a little guide for it. Here's a few of the versions of the clips that I went through. So I think this was the first version. I just felt this was a little too flimsy. And so I thickened up this here, but it gave us a little kink right here, and when you bend it, it actually puts all the stress right there, so that didn't look like it was going to last. And so then we did this one, and it's fine, but it takes too much pressure really to get those to close. So this is the last rev. And we will use 2 of these to lock in the top of the panel. Okay, we got the rear cover fittings all placed in, the 2 on the bottom and the 2 on the top. Alright, so this guy just slides into these 2 right like that, and should clip down, and then we just push it in here. There we go. Okay, moving back to front. So we got this panel done. The next thing is we got to put fuel ports into the tanks, essentially right there and right there. A return there and a take up there. Here's the sump bubble. We're going to need a pickup here and a return somewhere pretty close to there. Hey, here's a shocker. This flange and this flange are different sizes and require a different size hole. So if you measure for this hole and drill your 2 holes the same size, and the big one don't fit. Luckily it's fiberglass, and we have grinders. Obviously the problem here now is I got no way to keep the drill centered. However, we do have several of these, and if we just slide those on, there's the third one. All right, now we can keep it centered, and we want to push it down. It's not perfectly centered, but we want to make this a little offset anyway, since we set the position of that holes based on the size of the outer flange size. So anyway, this is worked okay on the other side. Let's see how it works here. And the verdict is, yep, cool. Here's the situation on the inside. Those are going to get floxed in, and one of the other builders suggested that maybe having the ability to get a wrench on these flanges in case you had to tighten these fittings down might be nice. Otherwise, you're 100% hoping that the flox job that you did on the outside, the flox and bit, is going to hold whatever torque you're going to put on it. And if it comes undone, then I think you're pretty much cracking open your whole tank to fix it. I like the idea of having some way to put a tool on these so that if I did need to crank on it, I can do that. Flats is a pain because you got to figure out how to get then you have enough recess for the wrench to get in there. But how about a couple of slots for like some pins? That would be cool. If I had a milling machine, that would be awesome. Oh, look what I've got sitting underneath some foggles and extra pottery. A milling machine that I haven't set up, and I've been waiting for a good reason to. There we go, a Makera Air unboxed. Makera Cam requires an internet connection for verification, otherwise it won't work, and their servers are down. It's a pretty expensive doorstop at this point. Boo! Boo, Makera! Continuing to work on the fuel system. These had sufficient clearance from the aileron torque tubes. And then right here I've got the fuel line kind of pre-bent, and that needs to go from here along this route there, and then along the back side of the seat to go to the fuel selector valve, which is in the front, not like John Denver's, which was in the back, behind the seat. But anyway, we digress. So what I wanted to do is just make sure the routing for that is okay, and then I think I'm actually going to go ahead and bond 4 of these standoffs to hold the fuel, and I'm going to set them out offset like this so that we can try to get the fuel lines not directly over the electrical lines. It would be nicer if we stuck these further away, but then we start to impact that torque tube. So 1 inch it will be, and that's the best we can do. So sometimes we can't adhere to all the things that AC43 encourages us to do. Okay, over here we got our first cut done on our new Carvera Air. Milled slots in the flange so that in the future, if we have problems getting something out and we want to build a tool to fit into those slots. Well, alright, here's our first project out of the Carvera Air. We just milled some slots into all of these flanges so that in order to get these completely ready, we got to do a few more things. We got to scuff them all up, and we're going to drill 6 or 8 holes in the flange for the flocks to squeeze out and kind of give us an additional bit of purchase. Okay, we're prepped to go ahead and install the fuel tank flanges. These are all cured. I've been thinking about it, and I'm just going to leave the peel ply on here because we've got several more steps, and might as well just leave it on. For sure, that tape that we put over the holes, we'll leave that on there so we don't get any debris inside those fittings. We're putting the experiment in experimental. These are rotolocks from, you can get them sourced out of McMaster Car. They're composites standoffs. Not click bonds. Click bonds are 10 bucks a piece these days. Not as easy as putting it as a click bond. It's going to take a couple of steps, but you know, I mean, the whole airplane's moving, so I think these things are going to be just fine. What we did is we floxed them in on step 1, and then we put some peel ply over the top. So what we'll do is we'll come back and we'll add a bit more flox to the top of those and a layer of fiberglass. And our fuel fittings came out pretty well. What we're going to do is just take this tape off and then cover at least this one probably with paper or plastic, because it's going to be, you know, I don't really want to leave this tape on there a long time because you'll get residue and whatnot. But we'll cover those up because they are going to remain not attached for quite a few months, and we just don't want debris or paint or anything like that getting on those, so we'll tape those off. Now here there are these, I don't know if you can see, there are 4 steel insets in this top piece here, and I drilled, they're not steel, they're aluminum, and I drilled through those so that when we paint we can still know where those are. I still need to cut a slot in the front, and then there's sort of a piece of aluminum with a nut plate that gets slid back so that you can attach the seat belts into that nut plate. Along the back, similarly, there are 4 insets in the rear spar that we will need to drill now while we can still see them before we paint, that will hold the seatbelt harnesses for the rear seat. We designed our shoulder harness nut plate and used the Carvera. Basically, the nut plate will fit in these 3 holes, and then these 3 holes I just put in so I can throw some epoxy in there, so when I slide it in with some extra epoxy, hopefully it'll stick up against the bottom side of the shoulder harness. And I'm going to make 8 because I'll just use the same design for the rear ones as well. Right, so these guys got all routed out with the Carvera. This one got picked up and chucked. Secondary operations, we had to just drill out these rivet holes and countersink them. Here's one that's been riveted up. The shoulder harness, what we have done is just fabricated a little bushing here that'll fit inside of here. So when we screw down, shoulder harness still can kind of rotate. Try printing this out of ASA and see how long it lasts. So you may recall constructing these nut plates that go into the shoulder harness. Underneath the shoulder harnesses, you know, when I drilled out these holes, they didn't feel right. It didn't feel like all wood or all aluminum. And turns out the previous builder had actually installed the nut plates and then covered them over. Anyway, not sure how I was supposed to know that, but bummer. Anyway, well, press on, we can fix it. Fixed. It wasn't that bad to get them out. Just have to replace them. That's how it goes. These are done. What we'll need to do is sand these flush, and then obviously make sure that we didn't get any epoxy on the nut plates when we put all this stuff in, and the same on the fore and the back. Hey, that's it for this episode. Thanks for watching. Like and subscribe if you like this content, and build on.